Hi everyone, welcome back to the class on antimicrobial classification based on mechanism of action. So myself Dr. Padmanabha TS, I will be taking you through the classification of antimicrobial agents based on their mechanism of action. So based on mechanism of action, let us see the antimicrobial agent classification. So please remember it can be classified into five groups. The first is those are the drugs which will inhibit the cell wall synthesis, and second one is the drugs which are inhibiting the translation, that is the drugs which are inhibiting protein synthesis. So next we have drugs which are affecting cell membrane, and fourth group we have drugs which are affecting nucleic acid. So it will affect the DNA as well as the RNA synthesis. Next we have a drugs which are affecting the intermediary metabolism. So based on the mechanism of action, the antimicrobial drugs can be classified into those drugs which inhibit the cell wall synthesis, those drugs which inhibit the translation, that is the drug which are inhibiting the protein synthesis, and next is the drug which is affecting the cell membrane, and the fourth group is drug which is affecting the nucleic acid synthesis, and the fifth group is the drug which is affecting the intermediary metabolism. So let us take up this individual groups. So first coming to the cell wall synthesis inhibitor. So you need to remember the easy mnemonic to remember the drugs which are inhibiting the cell wall synthesis. To remember this, you can remember it as friends binds to bacterial cell wall. So friends stands for F stands for phosphomycin. B stands for beta lactam. One more B stands for bacitracin, and next C stands for cycloserine, and the wall V stands for vancomycin. So how does these drugs will going to inhibit the cell wall synthesis? Basically, it will going to inhibit the key enzymes which are involved in the cell wall synthesis. So phosphomycin will going to inhibit the enol pyruvate transferase. It will going to inhibit the enol pyruvate transferase. So phosphomycin will going to inhibit the enol pyruvate transferase enzyme, whereas the beta lactams will going to inhibit the transpeptidase enzyme, transpeptidase enzyme, and the bezitracin will going to cause dephosphorylation of bactoprenol. So bezitracin will cause dephosphorylation of the bactoprenol, and the cycloserine will cause inhibition of the alanine racemase, and the alanine ligase, and the vancomycin will going to cause inhibition of the transglycosylase. So these are the drugs which are going to inhibit the cell wall synthesis. So just to repeat again, phosphomycin will going to inhibit the enol pyruvate transferase enzyme, whereas beta lactam will going to inhibit the transpeptidase enzyme, and bezitracin will going to inhibit the dephosphorylation of bactoprenol, and cycloserine will going to inhibit the alanine racemase as well as alanine ligase, and vancomycin will going to inhibit the transglycosylase enzyme, which are mainly involved in the strengthening of the bacterial cell wall. Next, moving on to the drugs which are inhibiting the translation. That means drug which are inhibiting the protein synthesis. Here you need to remember the ribosomal diagram. So as you can see, so this is the ribosome. So this is the 50S ribosomal unit, and this is the 30S ribosomal unit, and it has got the mRNA. On the mRNA strands, these two sites are present. One is the P site, one is the A site. A site is called as acceptor site and P site is called as peptide site. So please remember the nascent peptide chain which is formed already. It will be present on the peptide, that is P site, whereas the tRNA along with the new amino acid will be attaching to the A site. So following the attachment of the new amino acid into the A site, the next process will be so this is P, this is A. The next process will be, there will be formation of peptide chain, which will be attaching to the new amino acid which has been attached to the A site with the help of tRNA. So this is the peptide bond formation with the help of peptidyl transferase. Following that, what happens is so the peptide chain which is formed will be shifting from P to A site, P to A site, P to A site. So this is the new peptide. Along with that, there will be the nascent peptide attached. Following that, next process will be translocation. So what happens in case of translocation? This is the P site and this is the A site. So translocation, what happens means the newly formed peptide chain will be translocated to the P site from A. So now let us see which are all the drugs which can inhibit this process. So first we have a aminoglycosides. So these aminoglycosides will basically bind to the interface between the 50S ribosomal unit and the 30S ribosomal unit. So by binding to this site, so the amino acid will be binding here. So this is the site where amino acid will be binding, and what it leads to is it will cause freeze it will freeze the initiation. What it will freeze? It will freeze the protein synthesis initiation, and it will interfere with polysome formation, and also it will leads to misreading of mRNA. Thereby finally it will lead to inhibition in the protein synthesis. So keeping this diagram in mind, so let us see the next target site. Usually the tetracycline will inhibit the amino acid tRNA binding to the A site. So this is the tetracycline. So basically it binds to the 30S ribosomal unit, and it will cause inhibition of attachment of amino acid tRNA to the A site. So next we have a chloramphenicol will going to inhibit the peptidyl transferase. Mainly it binds to the 50S here, and chloramphenicol will going to inhibit this peptide chain or peptide bond formation by inhibiting the peptidyl transferase. Apart from that, we also have the drugs which can inhibit the translocation. So the drug which is inhibiting this translocation process is we have a streptogramins, we have macrolides. Next we have lincosamide. Sorry, it is lincosamide. Then we have a linezolid. So we have a streptogramins, we have macrolides, we have lincosamide, and we have a linezolid, which are going to inhibit the translocation process. So basically tetracycline will bind to 30S ribosomal unit, and it will inhibit the amino acyl tRNA attachment to A site, thereby subsequently it inhibits the protein synthesis formation. Next we have a chloramphenicol. So chloramphenicol will binds to 50S ribosomal unit, and it will cause inhibition in the peptidyl transferase enzyme, so which is the key enzyme which is involved in the peptide bond formation. Thereby subsequently there will be inhibition of the peptide bond formation, and subsequently it leads to or it inhibits the transfer of peptide chain from P site to A site. So this transfer of peptide chain from P to A site will be inhibited. This will be inhibited. Next we have a streptogramins. Then we have a macrolides. Then we have a lincosamide. Then we have a linezolid. So these all four will basically binds to 50S ribosomal unit, but linezolid will bind to specifically to 30S fraction of 50S ribosomal unit. So basically this will cause inhibition in the translocation. It inhibits the translocation of what? It inhibits the translocation of peptide chain from A site to P site. So the translocation of peptide chain from A site to P site will be inhibited. Next, coming to the third major mechanism. So the third major mechanism is drug which are affecting the cell membrane. So please remember, the drugs which are affecting the cell membrane, basically they will going to disrupt. Please remember, basically it will going to disrupt the cell membrane. So by causing disruption in the cell membrane, there will be leakage of the contents which are present inside the cell will be leaked out. So what are the content which are leaking? So the ions will be leaked, and also the molecules inside the cell will be leaked. So what are the examples here? So the Example is we have polypeptide polypeptide antibiotics. The example is polymyxin B, colistin and tyrothricin. So these are the drugs, polypeptide antibiotics, which will going to affect the cell membrane. So the exception is, so please remember, exception is the bacitracin. So these bacitracin will basically inhibit the cell wall synthesis. Although it is a peptide, it will going to inhibit the cell wall synthesis. Whereas the other polypeptide antibiotics like polymyxin B, colistin and tyrothricin will going to affect the cell membrane. Next we have a polyin antibiotics. So under polyin antibiotics, we have got amphotericin, nystatin, amikacin. Next we have a natamycin. So these are the polyin antibiotics. The next group is the azoles. Azoles will also affect the cell membrane. We have ketoconazole. We have fluconazole. Next we have a itraconazole. So these are the examples for the drugs which are affecting the cell membrane. Next, the fourth group is the drugs which are affecting the nucleic acid. Basically, it will going to affect the DNA as well as the RNA synthesis process. So first group we have is the DNA gyrase inhibitor. So basically this DNA gyrase inhibitor, or they are also called as topoisomerase inhibitor. Basically this enzyme is responsible for introduction of the negative coiling into the DNA strands following the positive supercoiling. This DNA gyrase enzyme will going to introduce the negative coiling by causing nick, and subsequently there will be sealing of the double-stranded DNA. So this process will be inhibited by the drugs like quinolones. So the example is fluoroquinolones, nalidixic acid. The next group we have a RNA polymerase inhibitors, or RNA polymerase inhibitors. Here the example is rifampicin. These rifampicin will going to inhibit the transcription process, protein transcription process. Thereby it will going to inhibit the DNA dependent RNA polymerase. It will going to inhibit the DNA dependent RNA polymerases. So next we have a third group, that is those drugs which are destroying the DNA. So which are the drugs which are destroying the DNA? We have metronidazole, and we have a nitrofurantoin, nitrofurantoin. So these drugs like metronidazole and nitrofurantoin will going to destroy the DNA by the release of reactive, please remember, by the release of reactive nitroradicals. So these nitroradicals will going to cause destabilization of what? It will going to cause destabilization of DNA helix. Thereby the DNA strands will be broken. DNA strands will be broken due to the destabilization of the DNA helix. The next group is the nucleotide analogs. So here the example is basically these drugs will going to cause faulty nucleic acid synthesis. So some of the examples are acyclovir, nucleoside reverse transcriptase inhibitor. We have non-nucleoside reverse transcriptase inhibitors. Next group is, fifth group is those drugs which are affecting the, please remember, this is very very important, the drugs which are affecting the intermediary metabolism. Basically these are the drugs which will going to inhibit the folate synthesis. So first group is they're going to inhibit the folic acid synthase, and second group will going to inhibit the dihydrofolate reductase enzyme. So this folic acid synthase is the key enzyme which are involved in the synthesis of the folic acid. So para amino, this is the PABA. This PABA will combine with glutamate and the thyroid. So this folic acid synthase is also called by the name dihydrothyroid synthase. This PABA will be converted into dihydrofolic acid. So the rate limiting enzyme is the folic acid synthase. So this step has to be inhibited. You need to inhibit the folic acid synthase. So the example here is here we have sulfonamides. Next we have a dapsone. Next we have a para-amino salicylic acid. So basically here the inhibition is of competitive type of inhibition, where increase in PABA will going to decrease the effect of this drugs. On the other hand, we have a dihydrofolate reductase inhibitor, where this dihydrofolic acid will be converted to tetrahydrofolate followed by synthesis of DNA. So this step is mediated by dihydrofolate reductase. So this will be inhibited. So which are all the drugs which are inhibiting this process? Example is trimethoprim, pyrimethamine, pyrimethamine, proguanil, and the methotrexate. So these are the various mechanism of actions, and based on the mechanism of action, the antimicrobial drugs are classified. So just to revise, basically, just to summarize, first class of drug was inhibiting the cell wall synthesis. Cell wall synthesis inhibitor. The most typical example you can remember is the penicillins or the beta lactams. Second group is those drugs which inhibit the protein synthesis. Here we have drugs which are inhibiting the protein synthesis by binding to 30S ribosomal unit, 50S ribosomal unit. So the drug which will bind to both of them is aminoglycosides. The drug which bind to only the 30S ribosomal unit is tetracyclines. The drug which binds to 50S ribosomal unit and inhibit protein synthesis is chloramphenicol, and we have other drugs which basically binds to 50S ribosomal unit, that is the streptogramins. We have macrolides, then we have got the lincosamide, then we have got linezolid. Then third group is drugs which are affecting the cell membrane. So the drugs which are affecting the cell membrane, you can remember it as polypeptide antibiotics, that is polymyxin B. Exception is bezitracin. Will going to inhibit the cell wall synthesis. Next we have got the polyene antibiotics. The example is the amphotericin. Then next we have a azole. We have got ketoconazole. Next, fourth group is the drugs which are affecting the nucleic acid synthesis. Here we have got DNA gyrase inhibitor. This example is fluoroquinolones. Next we have got the RNA polymerase inhibitor. Example is rifampicin. Then next we have got the drug which destroys the DNA. We have got metronidazole. The next group of drug is the drugs which affects the nucleoside. So these are the nucleotide analogs. Then we have a fifth group of drugs which basically cause the folate synthesis inhibition. Folate inhibitors. Basically they are going to inhibit the folic acid synthase, and other group of drugs will going to inhibit the dihydrofolate reductase. So here the example is we have got sulfonamides, we have got dapsone and para-amino salicylic acid. Here we have got trimethoprim, pyrimethamine, proguanil and methotrexate. So this was about the class on the antimicrobial classification based on their mechanism of action. Thank you.